So if you're here for irrigation water management, you're in the right place. We'll go ahead and get started. So I'm doing this session with Clark Carter, farmer from Mississippi, and I'm gonna go over. I call this an introduction, but it's really not. I'm really going to show you how to implement an irrigation water management plan. There's some case study work that we've done, or some actually implementing on some farms. This is part of that project I mentioned earlier at the general session, where we were comparing using irrigation water management versus the conventional practice farmers use. And if you look in USDA and look up what an irrigation water management plan, this is the official definition for NRCS for an irrigation water management plan. It's a process of determining, controlling the volume, frequency, and rate of application, ensured environmentally friendly and economically viable irrigation practice. And this is my definition. It's providing what the plant needs when it needs it. And that is the epitome of what we're trying to do with irrigation water management. It's just get the water to the plants when it needs it, not too much, not too little. So how do we do that? I talk all the time about this pyramid scheme that I like to promote, but it's real simple irrigation systems. It's just fundamental basics of how you ought to do irrigation. You start out with a strong base. That's your irrigation pumping plan. Do you actually have enough water to fully irrigate? How are you going to know that? You have to have a flow meter or know some way of assessing how much water you're using. Is it reliable? Can you turn it on and off without having to be there? Timers, things like this. Then once you've got a good water source, can you be efficient with the irrigation water? Can you get across the field and down the field? Across the field, that's computerized hole selection, pipe planner. Down the furrow uniformly is surge irrigation. That's how we improve our down furrow uniformity. If you're doing a center pivot, looking at your sprinkler package, are you uniformly applying water across the machine? And then other things like gypsum and deep tillage, you'll find you may have to do things like this to improve your irrigation efficiency. These are all part of getting water across the field to the plant. Once you can do that, then we need to look at timing water appropriately. Can we get water to the plant at the right time? How do you know what the soil water balance is? Things like soil moisture sensors, atmometers, ET gauges, ET-based scheduling systems. These are all things that help us understand what the plant needs when it needs it. But you got to get it there. So we would put, to see if this all works, we'll put a control field up, let the farmer put a meter on it, let the farmer do what he does, and we put all these practices and irrigation water management plan on another field that's comparable, same size, same variety, same soil type, if we can get it. So this is what it looks like. A flow meter. This is the farmer field. He punches his whole punch plan, does what he does, irrigates when he irrigates. And then we'll do the irrigation water management plan. So we'll start with the pumping plan if we can. Again, that's the meter. Knowing how much we apply each time we irrigate is an important metric. It'll tell you what's going on in the field. I've worked with many farmers that we get done after the irrigation set and we read the meter and we'll have applied half an acre inch of water. Now, how many days at peak water demand is half an acre inch? Does anybody know? Now you know. Anybody know?
Not even a full day.
About 2 days. Peak water demand is probably 1/4 inch a day, most of our crops. So you ought to be irrigating every 3 days, and I tell him that, and he's like, oh, we only irrigate on Monday. Well, you got 5 days where you don't have enough water. So knowing how much you're applying each time tells us if we're getting the water to the plant. We like these portable meters. We've seen through our data we lose about 20% of our flow rate through the growing season, so it's actually a moving target what you think you're applying. We found cost savings with doing looking at efficiency with pumps. I mentioned this earlier. We can save about $1,000 on electric well just by improving its efficiency. A lot of times motors are mismatched. Bowls need to be reset or impellers are worn. But the simple thing you can do to get a measure of this without going into detailed analysis of your pumping plan is looking at cost of water. And all cost of water is the amount of energy you use times the cost of that energy divided by the flow rate. Gallons per minute per acre, or dollars per acre. You can use a meter. We've done this with diesels. We just have a graduated cylinder and a flow meter and a stopwatch. That's all the tools you need, very low cost. And we have found savings on pumps. And at the other session, I'll talk a lot more about these and how we came up with these. that there's savings on the pump. So once you do the pump, now we can get water across the field uniformly. A lot of people are talking about hole selection. Clay's going to talk about that later. We've doubled our acres of hole selection in Arkansas in the last year. We use surge valves. Surge valves help us get water down the furrow uniformly. Jason Kreutz is talking about that. They will not always save you water. Sometimes you use more water with a surge valve. The thing about a surge valve is it's not a set management device. It is trying to get more water down to the back end of the furrow than you can with continuous flood or a continuous furrow advance. In Missouri, they have found it actually takes more water, use more water with a surge valve, but you get more yield as a result. In other soil types, you will use less water. So you really don't know with a surge valve whether it will increase your water use or decrease. At the end of the day, we should be using water more efficiently, and that's the thing to keep in mind with a valve. This is how we'll set them up. So with the surge valve, you have two sets. So instead, we'll break the field into a right and a left set to irrigate, and that's how they work. And then irrigation scheduling. Basically what we're trying to do is, in the soil matrix, after rain or after irrigate, we have probably saturated the soil. And within a few hours to a day, we'll drop to field capacity. And then from field capacity, the wilting point is our available watering holding capacity. And with irrigation scheduling, we're trying to stay in the upper half of this profile. So we always have enough plant available water, but we're not getting close to the wilting point. And that's what we're doing with sensors and atmometers. You gotta have a rain gauge. We like atmometers. I have a lot of success with them in Arkansas. They're a good $200. They're very simple to use. You can go to my website and use our chart and pick one up and start using it. They're specific to each crop type. We also have used a lot of watermark sensors with some kind of telemetry package. I like that because when I'm working with a farmer, I can see what they're seeing, and the county agent can see the same thing, and we're all looking at the same water balance in the field, and we can start talking about what's going on in the field and have a discussion. We try to get them in when they're early. I like to put rain buckets with them, and then we can see what's going on. We put our sensors in at 6, 12, 18, and 30 to represent the profile, and then we use that data back to adjust the surge valve and flow meter to see if we got enough water. Sensor tells me did I get water to the plant. If I did, then I make changes with the surge valve or the flow meter. Sometimes we'll use cutback irrigation, which will cut back or reduce our flow rate to try to get a longer opportunity time or get to soak better. And this is a lot of times what we'd like to see. We like to see, I give the farmers, this is saturation and field capacity, this is a trigger range, and this is stress. We want to stay out of stress. We want to try to keep our sensors in this green zone. And so that's what happens, what we should be doing. This is a farmer who didn't follow our recommendations and kept irrigating days before I would even bother calling him. And you can see we kept that field above field capacity the entire season. The average soil moisture profile will be dry on top, but the whole profile was above field capacity the entire growing season on soybeans. And he irrigated like 6 times. This is what happened. He would rain, and he would irrigate, and it would literally rain the day after. And we were still just maybe slightly above field capacity in some of the zones. But 3 irrigations right here, he didn't need to do. Didn't need to do it. He could have stayed home, right? So that's the value of knowing where you're at in your soil water balance. This is how we can use a surge valve. This is an example. This was our first irrigation, and you can see all my sensors for the most part were headed into the red. We could only keep the top one. We only affected the top soil moisture sensor, and so the next irrigation we shortened the advanced cycle because we got tail water too soon, and so the valve allowed us to keep water on the field a lot longer. We also came back again and hit it with a little bit more water, another advance. And that really changed our water balance. We were able to fill the profile back up with that valve just by changing the program on the valve. That's the only thing we did, and we ran a little bit longer. So here's one of the demonstrations we did. This was on a peanut farm, furrow irrigated. We saw 10 inches with the control, 6 with the irrigation water management. We improved his yield. This is what it looked like. This was driving me crazy, but we actually ran pretty far into the stress range. I mean, some of us were right at the edge for most of the season. This is the average soil moisture profile. Some of the sensors, we were really dry. But even with that, knowing how far into the red it went, we still saved him water and cut better peanuts. This is a cornfield that we could not get to soak in. We just pushed it with the valve as far as we could. Got about the same yield, a little less water, but it rained a lot. You know, only 7-8 inches was all it was needed, so we didn't start to accumulate a lot of difference. This is the one the farmer thought it was crazy, which is not unusual. We beat him on yield and used a lot less water on 33 acres. This is what I call my deer pressure demo. We had surge and hole selection on the same field. Those are kind of, and this is how it came out. We actually got a yield drag on our irrigation water on our surge side, but the conventional beat his control field. But the anomaly here, which always can come up, is that we had a bunch of deer pressure. Some deer came in and hit our side of the field really hard. It damaged the yield. We also, it fell off. And we tried to adjust for it, but some of the back had just dropped off, kind of different soil type, different slope. And so we weren't able to, so it's close, probably not significant. At the end of the day, it doesn't be significant, but we probably could have beat him, but we just kind of got a bad roll because of the deer and some other issues with drainage and so forth. So if you're going to do things like this, my message is, put them two real comparable fields so you can really see if these things work on your farms. That's going to be important for you to know. We found, we cut 25% less water, cut the same yields. We're saving around 2.6 acre inches on soybeans, and it's significant across all the commodities that we worked in. We did a deep tillage study looking at the deep tillage help in one of these demonstrations, and we found a 4 bushel increase with deep tillage, and I think that's because we had more water holding capacity in the soil, the plants were able to develop better root system, and so that was significant. We actually had it replicated in the demonstration, so we found that useful. Terminate on time, and so I'll kind of end with some of the lessons learned. One of our farmers liked surge irrigation so much he went out and bought surge valves for every field in 1 year without any cost share assistance. He thought in fact, he was taking the valve off and moving it around to the next field over. He liked it so much. Unfortunately, he didn't like the sensors or didn't use them, and we over-irrigated. And that's one of the dangers, is if you do that, because now you're getting water across the field really well, you're going to more likely over-irrigate compared to probably what you were doing. So that's one of the dangers. That's why these things all fit together. You can't just pick one thing up and start doing it and think that it's going to help. You've got to understand that they all fit together and interact with each other. The other thing we learned was where you saw the one with the red, one of the reasons we're in the red is because we're putting water on rice and we're not using multiple inlet. And so when I wanted water on the soybeans, because I'm waiting as long as I can, because we don't need it, let's put it on when we need it, we're still putting water on rice, and so we keep putting water on rice until we're done. Well, now we're into the red zone. We're getting worse on our soybeans. Well, if we have multiple inlet, we can shut the rice off, go irrigate our soybeans, and then come back to the rice as soon as we're done. We can't do that if we're not using multiple inlet on the whole system. Everything that pump services has got to have an irrigation water management plan. We can't pick and choose which fields. Got to be a system. So if you want to do something like this, I'll tell you a little secret. There is assistance to do this from NRCS. I set up an example field, 160 acres, soybean rice rotation, silt loam, with a pump. You have to do a whole plane, which means you do everything pumped to the sensor. Put a pump controller, a flow meter. We use computerized soil selection, a pipe planner. We put a surge valve, an anemometer, soil moisture monitoring unit on it. And this is kind of what it looks like. This is just an example. But these are all the practices from NRCS that it would fall into, all the codes, and how many of each. This is the cost. So it can range. So the cost on these sensors is really variable. But it can cost anywhere from $10,000 to $22,000 for this particular plant on 160 acres, right? A lot of money, right? 10,000 acres, probably not going to go over real good this year, right? All right, but if you go in and sign up, put this all in the Irrigation Water Management Plan, this is your payment from NRCS, okay? This is what it could cost, This is your payment from NRCS. They're not telling you much about it, right? Have you heard much about this? Probably not, maybe. All right. So if you need more information, here's my website, and I'll turn it over
The
to,
only thing is you have to apply during the.
right? Apply before you buy.
Yeah.
That's
but-
right.
And then they don't rake until the spring.
That's right. Long-term plan.
Right.
Don't need to do it this year. Plan ahead. Start with 160 acres. Don't do your whole farm.
Yeah.
Figure out what works, what you like, what you don't like. Worst thing I can say is you buy a whole bunch of sensors and decide, I don't really like this.
Find out if your county has money too.
Exactly. Don't go in there
That's right.
expecting to get that.
That's right. You go in with a plan. If you get it, yeah, that's right. Exactly right. Highly variable.